Hello together. We are Group 2 and we are going to present you today climate active gases and their abatement in the silicon industry. So there we start with the silicon wafer process. At first we start with cleaning the wafer. We create an oxide layer, photolithography, etching and adding ions. And as you already probably know, especially the etching process is highly climate active. A lot of hazardous gases are being created. Some of them are poisonous to us humans, to the environment, but also some are really powering the global warming. So especially SF6, C4, F8 and some other gases are highly climate active. We just looked it up. We wanted to find some figures for that. We found a Samsung report and it states the biggest levers of reducing these gases. And for example, Samsung can gain 56% of reduction via a process gas treatment to destroy these gases. It's even higher than the use of renewable energy. What we've learned is also a big lever of reducing these gases. So there we come to our problem statement and to our research questions. So we have the severe impacts from the semiconductor process, which we are tackling with abatement. In the past, there is just, as we've learned today, the dry bed absorber used, which helps to reduce the hazardous chemicals, but not the climate active ones. And we now want to reduce also the climate effects by using a burner washer system. So the questions that are being made to us is what kind of reaction products can occur in a plasma etch process, and what is the balance of a burner washer system? So in terms of CO2 emissions, and here we see the chemicals that can be eliminated by technical systems, and we watched the thermal wet system and it can eliminate these chemicals. And if you combine them, you can combine like a combination of these chemicals. Here we have the table of our gas flows, so what gases are being produced in our system with the wafer. And you see here, SF6, we have 72 grams per wafer in total, and per person, and 56 grams of C4F8. Here we come to the process that is being used. It's a Bosch process named after the company Bosch, I think. And we have always 3 steps there. It's the first starts with a polymer deposition of more or less Teflon. Then we apply some etch assist or sputtering with argon and O2. And then the third process is to silicon etch with SF6, which is also a very highly climate active gas. Here you also see, like, basically it's always like cutting out a very small chunk out of the silicon wafers, so to create these microstructures. Here you see the typical layout of a burner washer system. So from the etching process, all the gases are being collected and then via a pipe system are being led to a burner washer system. We have there the gas inlet and also some oxidant and some fuel, which is usually propane or methane. And that is being used to combust these gases into less hazardous, less climate active substances. And oh, can you go one slide back? Yes, and then this gas is then transported to the washer, and we use there some water and some chemicals to wash out some more other substances. Then, like, more clean is being let out to the air, and yeah, here we have also the unreacted products, the byproducts, and other products. So if we don't use the abatement, which is still currently in industry in some cases true, we have about 928 kilograms CO2 equivalents per wafer, which is quite a lot. It's like 1 ton. I think you can fly with 1 ton, like roughly to New York or something like this. It's somehow in the same size. And then if we use this abatement system, we can reduce it. It depends really on how effective the system is, because it has very high numbers. So if I have just a couple of grams of SF6, it has a climate factor by 20,000, something like this. So it really is heavily dependent on how effective my system is. We use there some statistics from a scientific paper, and we could, with these numbers, we could receive 15 kilograms, which is a 98.3 reduction. So there you see how effective such a burner washer system can be in climate terms. Yeah, there are some, but we don't get this basically for free. It's still, we have a more complex system than a dry bed system. So we also have some resource that we need to invest to get this reduction of 98%. So we roughly invest. I think that's methane, 0.92 kilograms of methane which accounts for 2.7 kilograms of CO2, which is like 0.3 of the total reduction we need to at first invest into our methane that we put into the burner washer system. Yeah, in climate terms, we invest a little bit and gain quite a lot, 3,000 times more than we invest. We also have some water usage. We need to use about 22 liters per minute of water. And yeah, that accounts then for 1 cubic meter of water per wafer. And yeah, you also need to somehow decompose this water and filter it, that you can let it out, because it has these chemicals. So there you also have some more effort you need to take in the sewage system. And there's also some PFAS gas slip in this gas remain that's being that passes out through the atmosphere that we cannot remove with the current technology so far. Yes, and that's all. Thank you very much.